Welcome.
Hello.
And good morning and good afternoon, depends where you are. Perhaps even good night when you watch from United States. Good morning, ladies and gentlemen. Nishman, Shenzhen, Wang Hao. And let's start the fourth E-Flight Forum China, where you have our sponsors, because this was also quite difficult because we always had sponsors for the forum, but getting an online forum sponsored was even more difficult, but we got it. So I hand over the word to our partner, Ms. Chen, who from Z-Park, who has made the Chinese side of this forum happen, like she's always done very great. For those of you who have been with us, it is definitely a great work what she's doing, also finding the different locations in China. But sure, I have to mention our sponsors at least by name. And the thing is great because we also in the sponsorship we are we have countries from around the world. So we have Rolls-Royce, location in United Kingdom, as everybody knows. We have Bosch from Germany, and we have Wolong from China. And so with this, I hand over to Ms. Chen.
We welcome you to have this meeting online. This is actually the fourth E-Flight forums, and this is also a platform which attracts international attention. I want to thank you, first of all, for your great support. And for 2020, this is a very difficult year for different walks of life. However, in e-flight industry, we do see a lot of progress. And we do believe that no matter what happened, we need to overcome the challenges and difficulties, and we need to continue this form of forums to let all the walks of life in this industry to understand the progress of e-flight and the electronic aviations. So hopefully with this platform, we can give you more details and more news and information. So without further ado, let me give the floor to our first keynote speaker, which is Madam Zhang Zhenmei, the Deputy Director General of Airworthiness Certification Department of Civil Aviation Administration of China. Welcome, Madam Yang. It is my great pleasure to be part of this forums for the 2019. Can you hear me? Okay, so for the past years, people pay a lot of attention for the e-flights and electronic aircraft, and people have great support for us. So we always want to be part of this great forum. So it is my great pleasure to take this opportunity to share with you about the following two topics. The first topic is about the Part 23 rulemaking for the e-aircraft. And for the second one, content I want to share with you is about the bilateral airworthiness between China and other countries. So next page, thank you. So these are the two topics I want to cover during this forum, during my presentation. I also want to invite my colleagues, Director Chen Ye from Airworthiness Department, and also Mr. Zhu Xiefeng, which is a research fellow of our Airworthiness Department. So they are the expert in this respect. If you have any questions, please ask them. And first of all, let's review the Part 23 reorganization abroad. And in 2011, FAA initiated the Part 23 regulation work with the objective to simplify and streamline the certification process, reducing the cost, while increasing the actual safety level in new entry-level airplanes. And at the end of 2016, FAA and the EASA issued the NPRM and NPA. And at the end of August 2017, the new FAR-CS 23 become effective or taken into effect during this time.
So during this time, CAAC actually sent 3 experts, including our colleagues, Mr. Zhu Xiefeng, who's here today. And those 3 experts have been working throughout 2017 to take part in this process. And they are in part of this reorganization. In the year 2019, we've officially started the reorganization of the rulemaking for Part 23. And after some very important key timelines, we've established our work. For example, in November of 2019, we've asked the public opinions and comments and organized the meetings to review. In December of 2019, the draft was submitted to the Department of Policy and Regulation. So as of now, we have another round of asking for the public comments and opinions and finished our review meeting. So the next step would be for CAAC to submit the draft to DOT for further approval. So what are some changes in our reorganization of Part 23? There are different categories and content. So first, in terms of the aircraft category, there's a change. So we take references from the international practices. So we had a normal categories, utility, aerobatic, and commuter. So they're now all categorized as a normal category. And we've looked at the seats and performances, and we divide them into 4 different categories. Moreover, according to the new requirement, the VLA is also included. So the bottom line is further extended. That means we have a larger and a more extensive scope for Part 23. That is, VLA is included in CCAR 23 as part of the normal category. So as we've mentioned, we won't have the pass categorization, but we will have the passenger seats and performance of the aircraft as our categorization. So we focused more on the security to categorize our content into 4 different areas. Next, some of other revision contents. So for the content of the original regulations, we've have more descriptive criteria. So some of the design criteria and the compliance method are transferred to the corresponding normative documents. So we have more normative documents of more detailed and specific level. So in the future, when we issue our Part 23, we will issue those normative documents as well. And also, our policy to review the engine, propeller, and the electric propulsion system. So the engine, propeller, and the electric propulsion systems are allowed to be approved under the airplane type certificate and no longer required to be type certificated independently. So this is another very major change. The next major change is that during our confirmation with the public opinions, when we are asking for the public comment, we know. Is there any issues? Well, there are no issues. Please go ahead. Please continue. So for those need and demand in our Part 23, the speaker's on mute. Well, let me continue. So we have 3 different categories for the development of the electric general aviation airplanes. So we have our requirement for the propulsion systems, for the battery and electricity distribution systems, as well as for the fire protection of the battery and the electric power systems. Well, sorry, we can hear some noises here. So some speakers is not muted. So could you please mute yourself? Our host, could you please mute one of the speakers that are not on mute? Well, next page, please. Well, we are trying to put up the slides now.
With the PowerPoint. 1 second. If you take it, if you can take it.
So we were muted.
Yeah. Yes, it's on the screen. Sorry for this. We have a little problem by getting the PowerPoint on the screen again. I see it here next to me on the presentation computer, but I can't see it. Is she screen sharing? No. No. But she has to share screen. Perhaps she is not share screen anymore. She is. Yeah. Ah, now okay. It's coming up again. Sorry for this. And we are at which slide? Is this okay? Thank you very much. Sorry for this.
Next, let me brief you on our updates for some of our bilateral collaborations. So as of now, we have 2 different types of agreement. One is between governments, for example, between China and the US, between China and Russia, China and EU. And the other type of the agreement and the collaborations are between the departments of government, for example, with Australia, New Zealand, Brazil, and Canada. So the bilateral agreement between China and the US was signed in 2005, which is BUAA. So after the signing of BUAA, in the year 2017, it is entered into force and we have the IPA. So you can tell from 05 to 17, when we sign and we eventually reached IPA, it took us 12 years. So all the photos that I'm showing right now is something that you can tell we have this long-term and close collaboration. And on the working level, we have a systemic understanding of each other, and we've established mutual trust. So at last, on this page, our director Xu, on behalf of AAD CAAC, have signed the IPA. So this is between China and the US. In between China and EU, in the December of 2017, we've signed the draft for China-EU BUAA, and on the 20th May 2019, Mr. Feng, our director, have signed into force our China-EU official BUAA, and in September 3rd of 2020, it is entered into force. So 2 days after it is entered into force, we have TIP, that is TIP. So we have the final signing and consultation and entered into force of our TIP, that is the TIP between China, EU BUAA. So At the same time, we also have this application, or rather the addition one of tip. So the tip is also part of the China-EU BUAA, and this is the principle that we've been following as long as together with their Appendix 1 and Appendix 2. The China-EU BUAA has learned from our scope of application. So after Brexit, it will be 27 members of EU. So that is the scope of application. So that also includes some non-EU members, that is 4 non-EU members, but they're under the EU regulation. So the agreement we signed with EU has specified our scope of application for airworthiness, and we shall follow the regulation of the EU. That is the common rules in the field of civil aviation. So for the larger commercial aircraft or helicopters, that is 650 kilograms larger, are under that scope. And for the rest, we will have other kind of agreements signed or collaboration with these different countries that is not under this scope. So as you can tell, this is the 20th of May of 2019, our director Feng, on behalf of the Chinese government, have signed official BUAA with the EU. For this photograph is after the draft of BUAA is written. So in the process of consultation, negotiation for tip, we took this photo. So after the consultation, I believe it is in January of this year, we started working in April of 2018. We worked all the way to January. So it took us a little bit more than a year to finish the consultation process. And just before the outbreak of COVID, we've finished the last and final consultation in Cologne of Germany. And on the right, those photographs were taken in September of this year. It is in the consulate of EU in China, and we've signed online the tip. So Director Xu from AAD of CAAC have signed the document on behalf of the Chinese government. And on the background, you can see there are a lot of our staffs. We have Deputy Director Hu, who've witnessed the signing. We've also have other relevant department, including the Political Bureau and our International Relations Department under CAAC, etc. So other than Director Xi, who signed the tip, on the tip, we also have an appendix. So that is under the scope of AEG, which is the work of the non-standard department of AAD. Mr. Zhu Tao have finished this part of the work. So that was the photograph on site. To summarize, in between China-US or in between China-EU, BUAA is an agreement between two governments in the field of aviation, including airworthy certification, the maintenance organization, the licensing of personnel, operation, air traffic control, and other areas related to aviation safety. And for the implementation procedures under BUAA, it would cover the design approvals, the production surveillance activities, the mutual trust, the mutual recognition, as well as the airworthiness approval.
So as you can see here, when it comes to the scope of cooperation, there are some cooperation agreements. They have some demands. For example, they want to have TC-PC separation. And probably there are some industry representatives in our audience. And in the future, they probably have a need like this. And also to separate TC and PC. So we will sign several papers to make that happen, and also to extend the scope of PC certification. And also for the type certification, we can have on-site certification for our overseas suppliers on-site in the future, probably. So this will pending for the future. So in terms of IPA scope of cooperation, also includes, could you please turn to the previous page? Thank you. Previous page. Thank you. So in terms of the actual process of execution of these agreements, it also includes the product. For example, includes civil aircraft, engine, propellers, and parts, and also some modification package. And also the acceptance or validation of design approval was based on these two principles. The first is based on the risk to determine the inspection method. The second is based on whether the other party is the CA or not. And also the other party shall be the CA during this process. This is the principle. When it comes to the acceptance of the production approval, this is based on trust, the mutual acceptance of each other's production surveillance system. So this was approved, and we have our own airworthiness labels on our products, and then they will be accepted by the other party. Next page, thank you. So in terms of acceptance of airworthiness approval, it not only includes the used aircraft and also the new aircraft. New and the used aircraft were all included, and also include the aircraft from the third-party countries. For example, let me give you an example. For example, let's take China and the United States as an example. If there's a product coming from Canada and they want to export through United States borders to China, and China as the importer of that Canadian aircraft, we can also accept that as long as it meets our IPA agreement's demand. Actually, the key here is that both parties into this agreement will accept third-party or even fourth-party countries' exports products. Another thing we need to keep in mind is that the current process will probably include some futuristic from future products. For example, UAV, we don't have a very clear-cut boundary for those products. So in the current process, there are some things that is still under negotiations, and there are also products, and we can also the achievements of extensive technical support and cooperation between two authorities can be reached, and also other categories of products not specified in the TIP agreements could be dealt through special arrangement on a case-by-case basis. So in the future, I believe that the bilateral collaboration will enjoy a very wide scope. So these are my presentation, and that's it from my side. Thank you, moderator.
Yes, thank you very much. And thank you also for having the time for us, because I know you must be very busy. This is also the only acceptance which we exception, sorry, which we have, that Ms. Zhang, she cannot stay until the end of the session because she has to rush to the next time. So if we haven't received any questions by now, I have some questions for you, which interest me. There is this interaction between the agencies, which is very important. How is the interaction going forward, especially on electric aviation? Can you give any, is this a kind of focus of CAAC? He's not translating.
Oh, first of all, we encourage that kind of interaction. And just like I've introduced before, Mr. Zhu Xiefeng, which is here, my colleague, will be the contact person for you, all of you, for interaction. If you have any questions, you can throw it to
Olaf has a question. Olaf?
To him. We can keep in touch.
So I have another question from one of the members, Olaf, who will speak right after you, actually has a question.
Willie, I cannot hear Olaf. Hi, Willie, I cannot hear Olaf. Hi, Willie, I cannot hear Olaf's question. Just asking Madam Chen if there are other questions. Okay, so we do have some question. One of the question is how many certified e-aircraft in China right now? That is one of the question from Olaf. And also about another question is about are there other relative policies about the airworthiness certification for engine plus aircraft? Hi, Madam Chen. When it comes to we do have a lot of e-aircrafts being certified for airworthiness, but we don't have a very updated number for that. If we have the number, we will refer that number to you, and then you can share it with our audiences. And the second question about the joint airworthiness certification for engine and flight. So for our P23, no matter what category they're in, they can be certified jointly with their aircraft plus engine. The engine is part of the aircraft, and so the engine suppliers could be the supplier to support the OEM of the flights to go through the airworthiness process. So it's the same with the past. We can regard it as part of the aircraft, but when it comes to the standards of the airworthiness certification, it's a little bit different. Okay, thank you, Secretary General Yang, and thank you very much.
So, good afternoon and good morning to everybody. I hope you can hear me well. If not, please let me know. My name is Olaf Otto and I'm the Director of Customer Business for Rolls-Royce Electrical. I'm very happy to be here to give you a little overview in terms of what our position, our view of the electrical power and propulsion market for aviation is. So if we can go to the next slide. Thank you. So let me just start by saying that it's great to be able to come to you and speak from a point of view of Rolls-Royce. Rolls-Royce has been in China for a significant amount of time. We have about 55 years in China's civil aviation industry, more than 2,000 employees currently working there, including joint ventures. We're powering over 500 aircraft. We're also supplying control and safety systems for China's nuclear power plants. So Rolls-Royce not only as an aviation supplier, but as a real power and propulsion supplier in the world. And we're very well represented, I think, in a number of regions of China, which is great, I think, for the presence in the country. So let me take you forward a little bit onto the aviation side of things. If we go to the next slide, please. So from a point of view of the electrical markets in aerospace, the markets really fall into different segments depending on the size and the requirements of the airplanes and the aircraft. And we believe that the application of different technologies depends on the usefulness for the specific segment. So if you look at the smaller aircraft, we believe that it's possible to fly these in all electric configurations. But as you start going into higher power aircraft and larger aircraft, hybrid electric or more electric does become more relevant and more meaningful. And there's a certain point where an all-electric aircraft ceases to be relevant, not necessarily just from a point of view of the technological feasibility. Using batteries, you can, of course, get even very large planes up in the air. But the question is, can you make an economic business case out of that? Can you build something that has a feasibility to work for the operators? The early markets from our point of view, small propeller aircraft, eVTOLs, and commuters. Now, each of these market segments has slightly different requirements. All of these in Europe in the CS23 class, even though they're in different segmentations. We believe that these markets are ready to enter into service. I think we will see the small propeller aircraft entering into the market within the next 2 to 3 years. eVTOLs have been in the news to an extensive degree. There's a lot of people working on this, and also here within this decade, I believe we will see the eVTOLs really taking off, as it were. There's already one company with Wolong JÖrg who has an eVTOL on the market, but I think there are many more that are going to be ready to join. I think one of the most underappreciated segments really is the commuter segment, though. This is a segment which has a large potential to be reinvigorated by the electrification promise. So we're able to build planes there that have commercial viability with the technology that is about to enter into service. And the commuter planes really can add a new dimension to our travel. The possibility that these aircraft are going to be cheaper and more silent and less polluting will really offer a potential to reinvigorate regional airports and connect distance communities. So from our point of view, These are three core markets. And if we go to the next slide, please, the aim and what we're doing within Rolls-Royce is actually preparing for electric propulsion systems to launch for these markets within this decade. So we have not only the motors and the inverters, but also the battery systems, the energy distribution, and further elements under development today. What are we doing in terms of development? Here are a few examples of things that we are working on today. Apart from designing and developing the eventual products, we're also still working on expanding the art of the possible a little bit. So the plane that you see here, the Excel plane, really serves as an aim to stimulate the electrical supply chain and to develop certain topics about the battery and the battery integration into the plane. And we've had the rollout of this aircraft already, and we are aiming to start flight testing as soon as possible, essentially as soon as the weather and COVID allow it next year, with the aim of breaking the world speed record for an electric plane. It's a very exciting project from our point of view. This is a little bit more on the lower end of the power range, but if we go to the next slide, I can also share with you a glimpse in terms of what we're working on for slightly larger aircraft. So this is the Aptus i5, for which we are building a fully serial hybrid electric power plant system, and you can see the system design on the bottom right hand side. So this is using a gas turbine from Rolls-Royce together with our Rolls-Royce motors in electrical and other electrical components such as the converters and the inverters to be a fully running serial hybrid system. We've tested the individual components already. We are in the process of finalizing build on some additional components. They're all going to be shipped over to Germany, where they will go into an integration with an aim to have this system flying by the time we reach about 2023. We've got a very extensive testing schedule that sits behind this. So quite an exciting project for a number of reasons. A fully serial hybrid system that is being demonstrated, very low rotational speeds at around 1,000 RPM, aiming to make the aircraft very, very silent. And then in terms of the application, obviously there are a number of applications that we foresee for this aircraft, from surveillance, reconnaissance, transport, to actually cargo applications, which could become very, very meaningful and very useful once you have them in a silent application. Not only in the fixed wing segment, if we go to the next slide, we've also been working for quite a long time on eVTOLs, and this project we've talked about in the past a number of times. The testing campaign that we ran in this year, or that was run in this year, was very successful, no malfunctions, a very exciting project working with our motors and our inverters and our electrical distribution centers, and really testing out some of the challenges that you have when you bring this kind of aircraft into the air. This is the most powerful eVTOL that has yet flown, and we've drawn a lot of learnings out of this already. And I think on the next slide we have a very nice picture also showing this from the side, showing it on the approach to its landing zone again. So it's been a very good learning curve, and we're taking all the knowledge that's been generated in this project forward in order to then produce the actual products that we want to have ready in this market. So if we go to the next slide. This is a small summary in terms of what we're focusing on at the moment. So we still have a lot of innovation that is ongoing. We are refining our equipment that we're building. We've started to bring first products into certification. So we have an electric propulsion unit that is on a certification path in Europe, with a concurrent certification in the USA with the FAA. So for us, it's really a question of now pushing items into that product path to make them available as products to the airframers. As we go on, of course, we have to work together with airframers and with other partners in terms of making progress here. This is not something that we can do by ourselves. Certification authorities have also been very, very helpful in all their approaches. And last but not least, it's a question about ensuring that we have the full supply chain stood up now, so that we can also deliver these products into a certified domain going forward. Thank you very much. I think we have a very exciting time ahead of us, and I'm happy to take any questions should you have them.
I hope my sound is now getting better. Thank you very much, Olaf.
We hear you.
And very interesting presentation. And Olaf and me, we know us already quite some time. Also, when you were making electric propulsion systems still under another label, because some people who are not that updated may wonder where Siemens Electric Aircraft stayed, and this is now Rolls-Royce Electrical, and it's great that you're continuing with so much energy to the further development. I think it's very important having large players doing this. So same as important is, like, we had authorities, we have a large industry player, now we have research. Our next speaker, our next guest is Professor Zhang from BUAA, Beihang University, and I think she will give us another aspect of electric flying. So please, yeah, we'll see. I think we still see Ole. Perhaps you can stop sharing screen, Olaf, because I still see your screen.
I'm not sharing my screen.
Okay. Yeah. Now we're there. Perfect. And then Shuguang. I can't hear you at the moment. I hope you're not muted. Sorry for this little technical problems.
Okay.
Now, yes, I hear you. Thank you. Perfect.
Thank you. Well, first of all, my appreciation goes to William, Mr. Chen, and to the entire team. Thank you so much for providing us with such a great platform during COVID, so that we can continue to share our opinions and we can seek further collaboration. So thank you so much.
The internet is down again.
This forum, I've attended for all the previous years.
I'm in the cable, so I'll make sure that it
gets this platform and this forum's contribution to the communication of the e-flight community. With the introduction of e-flight and the electrification actually brings about more possibilities for aviation. Of course, comes with it some issues and questions with airworthiness. And last year, we've put forth this idea. In China, we need a relatively stable team of experts to support us, so that we can combine and join our efforts to together promote the progress of our industry and to support the airworthiness standards. So in
It was good with the
2019,
session. We
last
didn't
year,
host the
we've
session,
convened
otherwise everything
our
would crash.
conference and
So in this
established
case,
the
it was really
Committee of Electric Aircraft Airworthiness Standards in Shijiazhuang. So let me brief you on what we've done in the past year. So this is a photograph of when we just started the committee. I think a lot of our participants today have witnessed this moment last year. So our motivation to establish this committee is that there are issues and questions with airworthiness and labeling. So we've established such an organization. And we've also gathered the support of the Chinese Society of Aeronautics and Astronautics, that is the CSAA. And the director of CSAA really welcomed and supported us. As of now, we are a committee under CSAA, and we are providing CAAC with our support with regards to rulemaking, regulation, as well as the communication with different enterprises. Next slide.
Yep.
So our purpose, as I've talked about, is to form a team of experts who are willing to work together to promote the development of e-flight and the electric aviation industry in China. We need to work with our international friends. We need to stay in close touch with each other. It is a great platform provided by William today, and it is part of this effort. And we also need to establish the airworthiness related technical standards in China. So I saw that some of our friends raised the TC questions, and I think this is something that needs the contribution of different participants so that we can gather the dynamisms and the latest development in this industry. So that e-flight and the electric aviation can be actually implemented on the ground here in China. So that is our purpose and our starting point of establishing such a committee. And after the committee is established, it is really welcomed by all in the industry. We have different members joining us. Of course, this is only part of the picture. We have other members applying to work with us. At the very beginning, we have some of our founders, organizers. We have the CAAC, Beijing Aircraft Technology Research Institute. We also have Wolong, CATL, Li Shen, etc. So we have more and more members joining us. So everyone work in the same team and they join in voluntarily. Doesn't matter when you join, you are part of us. We will also have individual members. Next slide. Thank you. So that was our expectations and our purpose. So this year, actually on the working level, we have some updates for different projects and programs. And we will have them as our speakers coming up next. And we've talked about the registration that include from Ruixiang, that is a two-seater aircraft, and the four-seater electric aircraft as right now is being TC'd under CCAR, and Yihang actually got the flight permits of FAA. For CAAC Beijing, they are working with UAM, that is the R3 VTOL released in this spring.
And also Geely TF2A, which is quite well known, they also issued the most updated TF2A. And in November, we also have the honor to witness the Auto Flight eVTOL series in November. And Mr. Chen, later he will give you the detail about the Auto Flight. And they want to have this logistics done by eVTOL. And also there are some non-conventional companies or institutions, for example, Zhejiang laboratories. These are just part of the story, and also there are also other representatives that have their own eVTOL association and their own eVTOL project that is under research and development. So I think that in China, what we worry about is about the general aviation industry. There are people saying that how can we expedite the process? Where is the market, and how can we make profit? This is people's concern. But actually, we are making these concerted efforts, trying to use technology, to use new technology to create the market by ourselves. So I think that over the past year, people are moving around to try to create a market for e-flight. And previously, Secretary Yang from CAAC have already shared with you about the P23. And now we have we are revising the draft of the CAAC's opinions on the airworthiness certification on the normal class aircraft revised draft. And also, in November, the State Council also required to accelerate the development of UAM development strategy layout and standard formulation to try to speed up the process. So this is from central government to support our e-flight industry. So this is the policy background of our market. Next page, thank you. So over the past year, as a expert panel institution, this is something that we did for the past year. First, we involved a drafting, we were involved in drafting the CCAR-23R4 subpart H documents, providing drafts and suggestions and recommendations during this process. And this year, another big thing is to draft new Part 23, Chapter H, Airworthiness Certification Guidelines. It is about the mobility risk of the e-flight, and also try to separate standards with demand. So this is the Part 23, Chapter H, Airworthiness Certification Guidelines. So this is one of the biggest things for this year for our committee, which is also a very heavy duty for us. Hopefully, before December this year, we can give you the draft of this new Part 23, Chapter H Airworthiness Certification Guidelines, and we also have already sent out the request for proposals. So hopefully that you can keep your attention on this. Another thing for us is about electric power systems for electric aircraft, which is a technical specification document for electric power systems of electric aircraft. This is under compilation, and next year there will be some overlap between the documents of technical specification with the new Part 23, Chapter H, Airworthiness Certification Guidelines. And now we're also trying to do something new, which is focused on eVTOL. And we will have a research project of airworthiness certification technology of unmanned electric power vertical takeoff and landing aircraft, which is eVTOL. And
okay, good.
We the CAAC Airworthiness Department gave us this job, trying to look at the airworthiness certification for eVTOL.
Tina, no, Greg is in.
Okay, sure.
These are some of the things that we are doing this year and for the last year. And of course, we're trying to provide service for China's market. In the meantime, we're also trying to join hands with our international partners. Actually, in fact, we are very keen to collaborate with our overseas markets. And Madam Chen have collaborated with Gamma to host a Asia annual conference in 2018. And also we have close talk with other partners. And of course, during the COVID-19 pandemic of 2020, we used to have some plans that cannot be executed. However, in 2021, we will carry out practical collaborations with other international organizations in order to push forward research, standard setting, and other activities. So these are some of our plans for the next year. Thank you. So overall speaking, using such a short span of time to share with you some of our research projects, some of our documents that we are compilating. I will not give you the details because the time constraints, but hopefully you can contact me in the future. You can give me some suggestions and recommendations in the future. And we do hope that for the e-flight industry can really take off and we can enjoy a promising future. Thank you very much. So thank you for your giving me this opportunity. Thank you.
Thank you, Shuguang, and it's really always very interesting to see how, and I will put my screen on again, how interesting to see how the international cooperation is working. I know that you work a lot with Munich University and with other people around the world. We will hear some other presentations from Munich University later, from the research, we go to our next speaker, who's Greg Bowles, who has been speaking at the e-Flight Forum in different positions. And now he is with Joby. I think everybody of you heard about Joby, who is one of the leading manufacturers of the eVTOL in the eVTOL field. And before he was at Gamma, which Shuguang just mentioned, and working for the whole industry. And he has an overview, I think, which will be very interesting for you because we talk about certification and he was working in this for a long time. So, and I have to mention one thing, we are in Europe or in China where it is either morning or afternoon. But Greg, he did get up at 3 o'clock in the morning for being with us. He's in United States. Welcome, Greg, on the virtual stage.
Thank you very much, Willie. I appreciate it very much. I'm going to share my screen here. Sorry. Here we go. There we are. So thank you very much. And I appreciate all the conversations so far on the early morning here in the US East Coast. And it's honestly, it's very exciting to see how fast the space has developed in China. We certainly have been working hard around the world on CS23, on Part 23, on global standards for existing new aircraft, electric aircraft, and eVTOL. And it's really exciting to see how fast this is all coming alive in China. So today, as Willie, you just said, I'm going to give a quick overview on the general certification path on a global basis for electric aircraft. And then later in the week, I will have a chance to dive deeper into how we certify eVTOL using those processes. So I think off we'll go here quickly. I think what's very important to recognize is that we are at a pinnacle moment. We're at a very unique point in time. We can't necessarily look around and continue doing what we've been doing. This is not an iterative point. If we were to look back in 1903, when the early piston engines allowed flight of the Wright brothers and certainly in France and other places in the world, and then in 1914, we started to see more powerful piston engines. Through the 1940s, the jet age occurred in the 1960s. That was a very important point for the world. Today, we stand at the beginning of the electric age of aviation. This is an age that will have huge impact on the globe, and it's exciting to see how fast China is working to industrialize that. All around us, we see changes in society. We see how we have evolved from the world of paper into electric, and that has provided a lot of access to information, a lot of access to data, and it has accelerated the expectations of people in society. Aviation has not kept up at that same rate, and electric aviation actually brings us across that threshold. So you could imagine for a second a telephone, an iPhone, or a similar smartphone that was powered by petroleum would not be very fast to update. But our electric iPhone, everything's electric, it's software driven. Once we have gone fully electric and solid state with these devices, their capabilities continue to evolve on a daily basis. And that's the world of aviation we're moving into. And that's a really important point. So once we get across this threshold of mechanical and hydro and petroleum systems working together into fully electric integrated solid state solutions for aviation, it's going to accelerate everything we do. And so the processes that CAAC is putting into place right now is really important. So to bring a new design to market, there are really 3 key ingredients to be able to commercially operate aircraft in a safe and globally recognized way. So there's been some discussion about this thing called the type certificate. So how do we type certify traditional aircraft, and then what's the difference for electric aircraft? The second is the operating certificate. So if we're going to commercially operate an aircraft, we have to do it under a commercial operating certificate. And then we need to qualify pilots to fly that aircraft, or we need to design the systems that take over that responsibility. So if an aircraft is going to be autonomous someday, it needs to pick up all the responsibilities and roles of the qualified pilot. And so those ingredients let us commercially operate the aircraft. So if we take one step down into type certification of the vehicle, this is the key conversation for this morning. If we take this look, the type certificate has a number of areas traditionally. So there are going to be requirements that are set by every government around the world. So this is CCAR 23, for example. Then we have methods of compliance. These are the standards and the materials we use to specify exactly the tests and the criteria that will hold the design to. Once we know the rules, it's one level below. It's the standards, it's the material we use. And then after this, we demonstrate compliance. So we know the rules that we have to meet. We know the details of the requirements for testing, and then we execute it. So we do the testing, we do the ground testing, we do the flight testing, we do the analysis. And the final piece is a verification. So an independent group, a regulator, or a delegated group will verify that all that testing was done safely and appropriately. And at that point, a type certificate can be issued. And if that process meets the bilateral agreements or ICAO requirements, it can be recognized around the world. So what's different with electric aircraft is first the area of rules. So in the rule area, there are some differences that we need to look at for electric aircraft. And in the means of compliance, there are some differences. But what's important to recognize is the process overall is the same. So the same 4 steps to certify electric aircraft. And the showing of compliance and the finding of compliance, those last 2 pieces are the same. So the processes are traditional, they work well. So if we take a look at the first block there, the requirements, there is a really great start under CCAR 23 R4. So that work is going to solidify the path for electric propulsion. I am really excited to watch the CAAC bring that into existence. I think maybe 10 or 15 years ago, I had the opportunity to work with a lot of the folks from CAAC on the earliest days of CCAR 23 and Part 23 and CS 23 and other similar rules around the world. I remember, in fact, we had a chance to go flying in the United States. If any of you are on the call today, it was a wonderful time to go for a flight in the US to show you the system in the US. The next piece is the methods of compliance. And this block here is today in the US system, in the European system, for CS23, we use ASTM F44 standards. And there has been great involvement from folks around the world in those standards. We had a really good briefing just a minute ago on CEAAS, CEAAS. And that group is standing up a range of new standards. I think one of the keys here just as with this first block, making sure these rules are very closely aligned around the world. So the closer the language of these rules can be to each other, the more easy it will be, the easier it will be to move these products and let Chinese products move around the world and go into commercial service around the world. This standards area is similarly important. So working together among standards organizations, for example, ASTM, EuroK, CEAAS, having these standards groups work closely together to set the same requirements is very important as an industry. And I will say what's exciting about this material is that this structure not only supports traditional electric aircraft, fixed wing airplane aircraft, it also supports eVTOL. And so from the Joby perspective, certainly we're very excited about the path that this material supports. The last thing I'll touch on is just a refresher of where we started back in 2015, when many of us began working this path, and where we are today. So if we were to look back 5 years ago, not very long ago, we would see that the world was not ready for electric propulsion. Within EASA, they had done a tiny bit of work, a little bit of work on sport aircraft, and China was just starting to get engaged with some of that as well. And Europe, the FA wasn't doing much. There was a little bit of electric discussion in small aircraft at that point. Within a year, China began to grow their information on sport aircraft and small aircraft. In Europe, there were some projects through Pipistrel and others to accelerate these kind of designs. Siemens, which is now the Rolls-Royce activity, kind of grew very quickly in those years. By 2017, we had seen the world really starting to wake up. Europe was beginning to certify active projects. The CAAC was standing up its rulemaking activities, engaged heavily around the world to design a regulatory set. It's continued in 2018 and 2019. And today, in 2020, we stand at a point where in Europe, they have a relatively robust way to certify electric aircraft. CAAC is now on the very edge of putting in place a new set of rules that will allow widespread adoption of electric aircraft, and that's really exciting. And so with all that said, I think I will tell you that I'm excited to talk to you later in the week about how we use these tools to certify electric aircraft. I feel very lucky to have been able to work with all of you, all my friends on this call, to help bring some of this material around the world. And I think what's happening in the next 5 and 10 years is going to happen really quickly, and it's going to be extremely exciting. So Willie, thank you very much for giving me a minute to lay out some opening remarks here, and I look forward to continuing conversations in the future days.
Yes, hi, and thank you very much, Greg, for getting up early. And like he said, he will be available also on Thursday on our eVTOL day, which is, I think, a day which I hope he can give us some more insights of Joby, because up to now, Joby didn't tell so much about what I was saying. So we were really surprised seeing how much they have been flying with their aircraft already, and maybe we get some more insights, and especially also on the certification side, because this is a big question. Like, we know now that eVTOLs are flying, but when they can be flying legally for personal transport, this will be the great question. So thank you very much, Greg. And our next guest is again a motor manufacturer, two motor manufacturers from a cooperation. We'll have Martin Dvorsky and JÖrg Janning, which is MGM Compro. And yeah, the presentation is coming up. Right now my screen has been blacked a little bit. I'm not sure what this is. But Martin, you're gonna give us an overview. Martin is working on getting electric aviation into the air quite a while with his company already in Czech Republic, and he has some interesting insights and news where he's going to talk about. Martin, it's yours.
Good afternoon, everybody, and thank you, Willy, for the word. As well, I would like to thank to everybody for the opportunity of saying some words on this conference. So my name is Martin, and I'm from company MGM Compro. Like Willy already said, a lot of our products are dedicated for electric propulsion, and as well, of course, for the electric aviation. If we can go to the next slide, I can tell some, let's say, general figures. So we standardly deliver the complex electric propulsion systems in the range of 10 to 100 kilowatt, but we have the project as well now going up to 400 kilowatt of continuous power. And our company has our own design and development and manufacturing facilities in the heart of Europe in Czech Republic. Yeah. So as well, the R&D and all of that is, I would say, in-house in MGM. Let's say our experience is almost 30 years as our company is focusing to electric propulsion almost since the beginning. So we have, I would say, long-term experience in this field, and our team consists of about 50 professionals. Currently, our goods and our products and our propulsion systems are exported to about 50 countries. If you can go to the next slide, I would briefly introduce our portfolio. So like I already mentioned, our main products are electronic speed controllers for electric motors, as well called inverters. And we have the controls for various voltages and various power ranges. So currently we are going up to 800 volts and up to 450 kilowatts continuous power. And another product from our portfolio as well belongs to the electric propulsion. So as the other products you can find in our portfolio, the BMS systems, we have as well very specialty one for the aviation uses with the doubled major parts and very unique self-check firmware. Then we produce and design the complete battery systems for the aviation usage with very specialty safety features, and as well fire extinguishing systems and stuff like that. And together with that, we offer the charging systems, and of course then we offer to our customers that we from the scratch deliver to them the complex electric propulsion unit based on their requirements. If you can go to the next slide, then you can see some of the project and partners that we have. Unfortunately, we cannot name all of them due to a lot of NDAs, but on this slide you can see that we delivered a propulsion, for example, for Airbus E-Fund and for Vector, EPOS, for many other electric aircraft, and as well as gliders. So we can find, let's say, the products of MGM Compro in many aviation projects, and I think that until these days we have most of the flying electric aircraft in the air. So if you can go to the next slide, here is some brief summary. And like I already said in my presentation, I will talk more to the particular project. So in a light sport aircraft, we have about 21 projects already flying, and about 20 of them in the development stages. In this sector, we talk about the power, I would say mostly up to 90 kilowatt, but we have as well the projects which are going up to 150. Of course, as well in this field, the certification will be the major topic pretty soon, in my opinion. So we are focusing as well with our partners into this field. Then, as another part, which were already discussed here, are the eVTOLs. We have about 15 projects running. Mostly the power that we deliver to this project is between 20 and 80 kilowatt per motor, but we have as well the projects with higher power used per motor. And in our opinion, this is forefront of the e-Aviation technology. Then regarding the UAVs, we have a lot of projects already running and flying, as well as commercial, with some partially commercial usage. There are about 18 projects currently, and mostly we deliver power between 5 to 30 kilowatt per motor. And there are really some of the interesting projects in the field. I will talk about them on the next slide. So then sorry, I forgot to talk about the self-launching gliders. This is already, in my opinion, existing part of the e-Aviation industry. So we deliver as well a lot of propulsion for self-launching gliders. On this slide, you can see one of the eVTOL project that MGM Compro is part of. This is the XTI aircraft, XTI Trifan. This ambitious aircraft already did the validation tests more than a year ago. The concept includes the 4 electric motors and 3 generators. So it's a hybrid aircraft, and MGM provides brushless electric motors, controllers, inverters, and as well some development capacities for this project. If we will go to the next slide, on this slide you can see the aircraft called Phoenix, and MGM Compro focused in this project on replacement of Rotax 912, and I would say then that this project is mainly focused as well on the flight range. Yeah, so we designed from the scratch the propulsion for this aircraft, focusing on a as long flight span as possible. And currently this aircraft can fly electrically, I would say up to 3 hours. We did a few hundred flying hours already with this aircraft, and we as well introduced the automotive charging in this aircraft a few years ago at Aero Friedrichshafen, where I think we were the first one using this technology as well for the electric aviation. If we will go to the next slide, you can see here the drone, the UAV from the Norwegian company Griff Aviation, and this is the example of the real UAV projects which are visible on the market. I would say this project has tough requirements on a safety, cooling, and as well on lightweight solution. And as a, I would say, interesting point, we developed a specialty redundant systems for the UAVs, which were used, for example, in a new space technology Qantas. And this technology allows to our partner Griff to replace their standard systems, which included 8 electric motors, and replace them with only 4 of them, and in my opinion, keeping the same safety level. If you go to the next slide, here we can see very interesting project. This project is a commuter class aircraft from Czech company e-Vector. The particular type is EV55, and this aircraft is using 2 PT6 engines, and our project is focusing to replace these 2 PT6s with electric 400 kilowatt electric motors, and sorry, this project is as well deeply focused on certifications, I would say, possibilities. Yeah, so for this project, we will deliver together with our partners the electric motors, and we will deliver the inverters and the complete electric propulsion, the battery safety features and charging, and we will focus on the particular DOs in this project, like DO 178, DO 160, DO 254. If we will go to the next slide, on this slide, there is, as you can see, the Wolong, which is a very famous Chinese company with a history of more than 120 years. And they include some of the very renowned European factories like the ATB and JÖrg. And as you can see, they are using the automatic manufacturing lines with the highest quality. And this high quality may lead to to, I would say, easy certification in the future. They are using European manufacturing tools, and this is all good and needed background to get to the certification. As you can see on this slide, they are currently working on a hybrid propulsion system, and parallelly they have the ongoing projects for the drones, and as well in 2021 they will introduce the propulsion drive for the fixed wing aircraft in Europe. Why we have the slide here is that we started a very interesting cooperation with this strong partner, and we are currently working on a common project for high power.
Hello, Martin. Just 1 second for interrupting you, because we weren't sure before now. The Jörg from Wolong, he's also in the call now, and he's unmuted, so he may join you there, because I wasn't sure before, just as information.
Yeah, sure. I can see Jörg. So
okay,
I will just
great. Thank you.
finish the sentence that currently we have a few of the common projects, and it's not a secret that we plan to work as well on EV55 together, and there are some other ones which are all focused currently on replacing the PT6 for a large aircraft. So this is our strong partner, and I think we will do a lot of interesting things together. So Jörg, if there is something you want to say regarding this slide, now the word is yours.
No, I think it's good how you said it. I think everything is said, and let's move on and wait for the questions.
Okay, sure. So then, like Jörg said, there will be definitely the potential to discuss the cooperation of Wolong and MGM during the discussion. So if you can move to the next slide. I would just mention here again that as all the previous speakers already mentioned, the e-Aviation is not the powering era anymore, and I'm pretty sure that now we will see more and more projects to be like to rise on the market, and of course the major topic will be the certification. So I'm pretty sure that there is very interesting future in front of us. If you will go to the next slide, which is the last slide of my presentation, I would like to thank again everybody for your attention, and I look forward to your questions. Thank you.
So thank you very much, and interesting insights. We have a little problem which we always have in our forums. We're a little bit, and I switch my screen on again, we are a little bit behind of time. So we don't have questions here. We will have the breakout session with questions afterwards. And the good thing is we see that the communication channel with the chat really works well, because in the chat we see a lot of questions asked and already answered by the speakers after their presentation. So this is really an advantage which you don't have in real conference. And so thank you very much. And now our next speaker, I'm honored to have Tina here, whom I know for a very long time. And Tina is working on electric aviation since the beginning. And they started already with electric motor gliders when most of the other people still thought that this is something which never will get to any market. They had the first aircraft to the certification, and they are also in the eVTOL sector very present. I leave you to explain how. Thank you, Tina, and thank you for being with us. Tina is muted. Can you unmute? Tina, you're still muted.
I think I should be.
Now it's better.
Hi, everyone. Good afternoon to China. Good morning to the US. Early morning. Good morning to everybody from Europe. I'm honored to be here. Yes, we started flying electrically much before it was cool, and we've tried interesting things. I would like to walk you through what we believe is actually important as we go forward based on our experience. So on the first flight, there is our large cargo moving UAV, hybrid electric, which I'm sure you will hear a lot about in the future. But today, I think it is time to reflect on the experience in order to draw certain conclusions on how to best proceed for the future. So can you please advance the slide? Next slide. Yes. So Pipistrel is a family-owned company, approximately 300 employees, focused on 3 European locations, as well as setting up a major presence in the vicinity of Nanjing, in the municipality of Jurong, an air park, as well as a production facility. The company was established in 1989, so we've been busy with aviation in different ways for a long time. But since the very beginning, Pipistrel promoted affordable flight. This basically meant first simple flying machines, then a migration to composite materials. All of our products are composite materials built. And as of 2007, we made the switch towards flying electrically. Next slide, please. So at the moment, we produce 12 different models. 3 of them are electric, more and more every day. And as of this year, Pipistrel is actually receiving more orders for electric aircraft than the rest of the aircraft that we produce, which still use conventional powertrains. So it's a very exciting time to be in. Our production rate is quite high, 1 aircraft for every working day. So between 220 and 250 new aeroplanes leave to customers across the globe. Our presence is in 97 countries on all continents, also China. CAAC has validated type certifications for our aircraft, and we are able to serve both private, government, and fleet customers. Next slide. Coming to one back. Okay, coming to electric flight, this is the timeline of projects that either Pipistrel did on our own or with partners. It started in 2007 with motor gliders. In 2014, with Siemens e-aircraft, we flew the WhatsApp project, which was really the foundation for the first type certified aeroplane with EASA. This year, we flew aircraft powered by hydrogen. This was a project led by DLR and H2Fly, where Pipistrel was leading the flight test campaign in 2016. So it was an interesting hands-on experience, as well as quite a complicated exercise in certification, even for non-commercial operations, just because the technology was so cutting edge. Then Alpha Electro started to ship to customers in 2017, and this year important milestones, EASA type certification for the engines as well as the aircraft separately. For early next year, we are looking forward to demonstrate hybrid electric flight with the hybrid Pantera as one of the 2 aircraft flying in project Mahepa, and the German Aerospace Center DLR with H2Fly and University of Ulm will be flying the next generation of the hydrogen-powered HY4. So we've seen battery-powered aircraft, hydrogen-powered aircraft, electric hybrid aircraft, as well as engines. So accumulating this kind of experience puts us in a very good position also for eVTOL and more complicated projects in the future. Next slide. So when one discusses certification, and I like what Greg Bowles was saying before, of course, the primary focus goes on the product, on the aircraft itself, where it matters which aircraft category you are putting it in. This then also unlocks or disables certain operations. But it's not only the aircraft, it's the propulsion, namely the engine, the propeller that needs to certify, but then of course also all of the processes which are needed to consistently and in a quality way produce your new products. So Pipistrel is a holder of the EASA production approvals as well as design approvals, and we are quite proud that we are able to do a design from scratch to certification in-house. But what really matters for the operations is actually not just the aircraft. It's the operational rules, it's pilot licenses, it's questions about maintenance. You know, existing mechanics have not been educated about hybrid powertrains, about batteries, about high voltage specifics. And the similar situation is with first responders, with fire brigades on airport, off airport. These people just don't expect that electric aircraft are coming. So a lot of work has been done between Pipistrel and national authorities as well as specialist agencies so that this content can become part of future standards. Next slide, please. So Pipistrel has contributed to ASTM, SAC, and also Chinese-led initiatives since 2011, and being part of these groups and being able to share the knowledge has unlocked certification paths. So in this year, Pipistrel was able to secure exemptions in Europe that allow the Velis Electro as the type certified aeroplane by EASA to be used commercially, to be used for pilot training. And this is also because the engine was certified separately and because the batteries are compliant to the very stringent DO311A standard. Next slide. So when one is discussing battery certification, there should be no shortcuts. Fact is that battery cell manufacturers are unable to secure quality control of each separate battery cell. So the battery packaging and safety solutions have to be robust enough to handle surprises, not only when the battery is new, but also when it ages. So particular attention was given to adequate testing, which was witnessed by EASA. All of the blue cables you see here on the test article, the silver box, which is the battery of the Velis Electro, is only for measurements inside the battery pack. So this is a fault-tolerant battery pack, fully compliant to DO311A, and it is also crash-worthy. So drop tests were performed on battery packs separate from the aeroplane, as well as part of the certification to ensure adequate levels of safety for the operators of the Velis Electro. Next slide. So why are we doing all of this? Of course, there are environmental reasons. It makes sense to look into the future that is cleaner, brighter, and delivers a better quality of life by not emitting as many emissions as we all do today, also when it comes to flying and air travel. But the other lucrative component is also costs. So in 13 years of experience, Pipistrel has developed in-house capability of battery design and certification, battery management, our own engines, cockpit instruments, chargers, the whole portfolio. And as we are able to tightly integrate these technologies, the operating costs are quite remarkable. So something in the order of 30 to 40 euros per flight hour, which includes the depreciation of the aircraft, really changes the game when it comes to pilot training. And these are real life performance from airplanes that fly with customers every day. Next slide. So Velis Electro is a two-seat standard category aeroplane with flight endurance of approximately 1 hour with all the reserves, but it meets safety standards that are the same or better for any normal category aeroplane. So I think it is an achievement on its own, but it is also a lighthouse, a sign for the industry that certification is possible, that also a small company like Pipistrel can deliver these products. So hopefully others will follow very, very soon. And Pipistrel is excited about all of the regulatory standardization and technological developments that are happening on the globe at the moment with this accelerated pace. And we look confidently into the future, also upscaling the size of the products as well as moving into the VTOL segment, especially when it comes to logistics and cargo delivery as the first applications in years 2023. So thank you, and I will be open for questions you may have in the chat or in the breakout rooms.
Okay, so thank you very much, Tine. Let me switch my image on again. And I know if we would have you talking about all the project you're doing and all the project you would be in, you probably could talk all day. And the problem is then you couldn't work on any further projects. How can you get eFlight Journal? Just scan the QR code on this page. Or just type in your browser www.eflightjournal.com. Then you receive the page with the latest online news on electric flying, eVTOLs, and everything which is connected with electric mobility in the air. Or you can click the link on the top and then you go to the latest PDF version, which you either can read in the Yumpu reader directly on your screen, like a conventional magazine, or you can go and download the magazine as PDF file so that you can read it offline wherever you want. Thanks for watching and goodbye.